Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as Assistant Professor at Sharad Institute of Technology, College of Engineering, Etra, Ichalkaranji, and which is in Kolhapur district, Maharashtra. Today, in this video, we'll go through the automatic program tools, part programming. As we had gone through part programming, they would, we have gone through programming languages, APT language structure, geometry statements, even the motion statements. And now we are here to look out the motion statements in programming. So let's start with APT part programming. We'll take one example. On that basis, we'll see how to write a program. So this is a problem. Write an automatic program tool, part programming, to cut the profile as shown in the figure. Write an automatically programmed tool of part programming to cut the profile as shown in this figure with a cutter of 6.5 mm diameter. Cutting speed is of 900 rpm and feed rate is of 7.5 mm per minute. These three data are given, or we know this, or our machine tool is of set with this tool and cutting speed and feed rate. So we'll look out the figure first. This is 100 and this is 150, right? And this is 150. If you say this is y-axis, this is, if they say this is x-axis, so from initial from here to here is 100. Again, if 50 come back, this would be 100 minus 40, this would be 60 here, and again this would be 100 because this is 150, this is minus, this is 100, and again this is 40, again this is 150. It's like that. And here the curvature is there of 25 mm radius. So first of all, we have do such kind of things. So we'll first name the points here. Start with the p0, say x and y axis. So you put a PO, then you write just P1 here, P2, P3, P4, P5 and P6. On the drawing paper or drawing, we just make this drawing and make up points and P0, P1, P2, P3, P4, P5 and P6, right? Next, this one is line L1, this is line L2, this is L3, this is L4, and this is L5, and this is L6. So this is the line routine, right? L1, L2, L3, L4, L5 and L6, right? Then this one is a C1 and this one is, sorry, this one is C1, that is curvature over here. So just write on the paper before you start a program. Now we'll see how to do it in program. The the component is labeled to define the geometric as we have here shown. Next, part number. this is 1. So this is, if you say multi parts, we can say a different part. So here this is part number /01, right, program number. Next, machine. What kind of operation we are going to do? This is a milling operation, right? And intolerance of intolerance means, as we have seen, that is, intolerance means the inside tolerance indicates the allowable tolerance between the inside of the curved surface, inside of the curve surface and the straight line segment used approximate curve. And similarly, that we have set in 1 micron or 0.001. Next is out tolerance, that is outline tolerance. So here we said the tolerance are specified outside tolerance, as inside tolerance we have inside and this is outside, and here outside tolerance indicates the allowable tolerance between outside of the curve surface, outside of the curve surface and a straight line used to approximate in the curve. So this is what we have set the tolerance. Next is cutter. Come from a cutter, which the cutting tool, we need to set commands first. So in that we need to set a cutter as well. Cutter is of having 6.5 mm diameter. So this is 6.5 mm diameter of cutter, and spindle speed is of 900 rpm. So spindle slash 900 rpm. And what is the feed rate here? We have got the feed rate is 7.5 mm per minute. So this is feed rate, that is 7.5 mm per minute. So when it starts, the coolant also get start. So put the coolant slash on. Next, come to the point to point motion commands now. So coolant on, when coolant on, that point P naught, that equal to that P naught we need to set. So how could you say point, this is point slash, from here to here this is minus 25.0, this is x-axis, again minus 25.0, this is below P1, from here this is what, minus 25.0, and z-axis is 0 0, isn't it? So there are two axes, so z-axis is totally 0 here. So we have set this PO for x and y axis. Got this? Then P1, point P1 here, as we have taken 0 minus minus, from here this minus and this is minus, so now here 0 point. Yes, in this point all the coordinates, means x, y, z coordinates, are 0, because we started operating or machining over here from this point. So we set this P1 as x-axis is 0.0, y-axis is 0.0 and y-axis is 0.0. Next, come to the point P2. Come to the point P2. We need to set a P2. From here to here, how much P2 is? X-axis is 150. Y-axis is from here, y-axis is 0 and z-axis is also 0. So we have to set here P2 is 150.0, y-axis is 0 0 and z-axis is 0.0, isn't it? So next P3, next is the P3 point here. From here x-axis is 150, y-axis is 40 and z-axis is 0 here. So see here P3 point, x-axis is 150.0 x-axis, and y-axis is 40.0, this is 40.0, and z-axis is 0.0. P4, if you say P4, this point P4, so x-axis is how much? Is 50, isn't it? Y-axis is 100 and z-axis is 0. Yes, so P4 is 50.0, 50.0, and y-axis is 100. This is y-axis is 100, and this point, and z-axis is 0, 0, 0.0. And P5, come to the point P5, point P5, x-axis is 0 here, so x-axis is 0, so 0, 0, 0.0, y-axis is 100.0, and z-axis is 0.0. This is what we have set, and now we need to set P6 as well. At P6, point P6, this is point P6, and this radius is how much? 25.0, that is 25 mm. So this is the point P6. So if you see here, this 50 plus 25 plus 25, isn't it? So how much it is? 50 plus 25 is 75. This is in x direction. This is x direction. And what about y direction? This 40 plus 25, that is 65, isn't it? So x-axis is 75.0, y-axis is 65.0, and z-axis is 0.0. Come to the point line 1, where line, that is from here to here, P1 to P2, from P1 to P2, line to P2 to P3, line slash P2 to P3. Are you getting this? Next, C1, the C1 circle, that circle at the center is P6, center is of P6, and radius is of how much? 25.0, isn't it? Right? C1. Next, L3, this is L3, P3 to C1, isn't it? P3 to C1, that is what? From left, right? Left. See, line P3, line P, sorry, that is line L3 line slash P3, from P3 to C1 in the left side, that is TNTO, that is TNTO. TNTO is, we have that moves the tool to point out the tangency between two surfaces, isn't it? At least one in which is circular, as we know, right? One which is circular. So tanto is the tool, moves the tool to point to tangents between two surfaces, in at least one of the which is circle here. Are you getting this? Circle comes, so it would be tanto up to C1. If it is straight line, we would use this direct P1 to P2 like this. If this is circle, so we use tanto. Are you getting this? So next, L4, this is L4. See here, P3, from P3 to right, P3 to right, this right, and tanto C1, from tanto C1. Again tanto, why? Because it's two surfaces, it moves the tool to point of the tangent between two surfaces, at least one in which is would be circle. So this would C1 to P4 to C1, you just say PC1. But how the line 5 is moves from point P4 to point P5. Here is no circle at all, a curvature at all, so directly you have to put from P4 to P5. Again, here is also no any kind of circle or curvature, so again the line 6, that is P5 to P1, it should be L6. Okay, then PL1, that is plane 1, that is of PL1, PL2 and PL5. PL1, PL, PL1, PL2 and PL5. This is what the surface, or sorry, plane, and from slash PO, from slash PO means starting from here. So this would be a rapid fast process. Now go to, this is what point to point motion command, go to, and this is go is, this is used to bring the tool from the starting point against the dry surface, part surface and check surface, right? So this is what go to L1, PL1, plane 1. This is what a plane 1, on this plane 1 we have set here plane 1, PL1, and again to L6, again to this, come here again this L6. Next GO to PL1, again it comes to PL1, go to PL1. Now if you see GORT L1, right side, go right side at all L1, this is L1, and past L2, this is past L2, means you have to go like this and past L2. Similarly go right L2, go right L2, right L2, and past L3, past L3. This is from here to here, this is what left, so go left, L at L3, on L3, that's 10 to C1, 10 to Y, this is curve here, right? Similarly go forward L4, go forward L4 and past L5, that is past L5, go forward and past L5. This cutting tool is going on, so one curve is already passed and this is L4 to L5. And then go left L5, go left L5, that is past L1, that is past L1, this is what L1, so it would be passed to L1 like this. And then go left L6, go left from here, go left to this L6 and past L1, so it could be past L1, L1 past means ahead of this L1, right? So again go to PO, again tool comes over here, the tool comes past L1 means above, means through the L1 like this, up to not here, it should be past the L1 like that. So it comes like this up to here, or it may be here just past L1, then again it comes tool is here PO, point PO here, and then process is over. Then you can say that coolant is off and spindle is off and finished, and this end. If you done like this, this part has been successfully done with this part programming. So we'll see another problem, same kind of, we'll see here. If you see, write an APT program, part program for the profile as shown in the figure here, with a cutting speed and feed rate of 500 rpm and 100 mm sorry 100 mm per minute, that is feed rate. This is a spindle speed and respectively, that is cutting speed is 500 rpm, sorry, and feed rate is 100 mm per minute, and the cutting is of 10 mm diameter. Use macro statement for drilling operations. as we had gone through the macro, that is symbol would be named the macro, that is called you can say call symbol and parameter specifications even. As the sequence similar a statement which needs to be referred more often, the part program are best referred by the macro, as we have gone through before a video. This feature is similar to that subroutine in Fortran and other computer programming languages. And the macro subroutine is defined like symbol first, that then macro slash parameter definition. We'll see how it is. And this is what a given diagram, and we need to find this. We write to part automatically part programming tool and part program for this figure or job. So now if you see a solution, just write on as usual as before we have saw the previous problem. Put P0, P1, P2, P3, P4, L1, L2, L3, L4, and after P4 you just P5, P6, P7, P8, P9, wherever you put the numbers, however you put numbers, doesn't matter. Only the thing is, while writing you need to care of, right? This is dimensioning of Cartesian coordinates, right? So now come to the point solution, that as told you that patron part part number 2, as previous one is part 1. So similar machine, if you want to do this, so you have to put this is part number 2, and machine, this is what milling 0 5 1 2 3 4 5, so milling operation 5, and the CLPR CLPRNT, clear point, CLPRNT. And then next here come to point, that is spindle is 500 speed and feed rate is 100 mm per minute. Next set this is point P0, this is minus 25 and this is minus 25, and y-axis is 0, y-axis is 0. So now P1 is point 0 0, x-axis 0, y-axis in z-axis 0, so starting point is here. Yes, then now P2 point, P2 is here, the length is given, this is 90, this is 90 and this is 45, right? We'll take together so we'll understand better. Yes, now P1 is here, this is 0 0 0, x-axis 0, y-axis 0 and z-axis also 0. P2 is x-axis is 90, x-axis is 90 here, y-axis is 0, y-axis is 0 because we have set P1 is 0 0 0, and so P2 is 0 0, sorry 90, this x-axis is 90.0, y-axis is 0.0 and z-axis is 0.0. Next P3, next P3 point, this is P3 point, so x-axis is how much, this is 90 and this is 45 in y-axis, so write 90.0 comma 45 comma 0.0, right? You need to write 0.0. P4, similarly P4, x-axis is 0, y-axis is how much, 45, y-axis is 45 and z-axis is 0 0. So this is what 0 0, 45.0 and 0.0. Then 0.5, 0.5, where is 0.5? Here, isn't it? So 0.5 is here, so x-axis is 15, y-axis is 10, isn't it? And z-axis is 0, 0. Yes, so we have to write 0.5 is 15.00, 15.00 from here to here is 15, and this is x-axis, y-axis is 10, and z-axis is 0, 0. Similarly, P6, P7, P8 and P9, just we have to write as previous. Similarly, L1 from here to here, L1 line P1 to P2, L2 P2 to P3, L4 P3 to P4, and PL1, PL line 1 is plane at that 1, 2 and this 3. This line we have said that plane surface, right? Next, coolant on, and then from PO, coolant on, and the process machining starts from the point P0, right? Next, now see here, from PO go to L1 to PL1, tolerance is of 4, right? Tolerance is of 4. Sorry, there is not tolerance, that is 2L, 2L4, 2L4, right? So here go to L1, go to L1 to PL1, that is already we have set this PL1 to PL, so TL4 to TL4, then go right, L1 past L2, L1 this past L2, from this is L2, so past L2, forward L2 from past L3, so forward L2 past L3. Similarly, go left L3, go left here, go left L3 past L4, go L3 past L4, this line has to pass, this past it. So similarly, go to PO again, then come to find drill, take out drill, that is macro at PX from XX, right? So go to PX, so we need to set that PX, then in GO DLTA, what is that GO DLTA? This instructs the tool to move from the present position 1 unit in X direction and 2 point, sorry, in X direction and minus 10 unit in Y direction, isn't it? So again, from this GO DLTA 0, 0 and 10, this is in Z, it should be yeah, 10 minus 10, 0, 0 and minus 10 and 10, and then TRMAC. So next comes here that very last statement is that TRMAC, right? All the statement that encloses between micro statement and the TRMAC statements are to be executed whenever this micro is called. So this is finished here. Then from PO, from again PO, call drill PX, that is PX is we have taken this X wherever we have to do drill, then drill PX, that is P5. Similarly, drill PX, that is equal to P6, then drill PX, that is P7. Similarly up to here, then next wrap it and then repeatedly and go finish, and then go to PO, again coolant off, and then spindle off, then end. I didn't it missed out here. So after rapid here, we need to go like, go to again PO, it tool comes to be in the initial state PO, then coolant off, as we have see here, coolant off, then spindle is off, then finish, then end. So after that, this program is saved, and then we can do the motioning. So this is what APT part programming. So we'll see a next video in next on next topic. Thank you one and all.